Okay. So thank you, Alistair, and thank you, John. I think it is quite interesting, and we see that we have a lot of challenge. I don't know what I will be able to see before my retirement, but I think it will be ready for a second life. So this is quite a big challenge. This is nice to see this grand vision. Can you start? Okay, so this is what I present this morning. It's kind of a high-level view on where we want to go, but we talk about the digital twin that we want to see we want to put the control center in the loop. So we want to try to help the operator that will have more and more difficulties to manage the low inertial system, because the decision time will become smaller and smaller, and then it will become more complex to operate. So can we have, in parallel with the power grid, a simulator that will have a very detailed models for some zones that are very important. Some other zone maybe will have more estimated model, but the idea is to have a very fast model that will run in parallel with the grid, where we can inject the status, how the state, but we can inject many test scenarios. So we'll be able to predict the stability, power transfer of the grid every 5 to 10 minutes, so to make sure that if something happens, we are able to come back on our feet. So we are able to resist to many contingencies. And also maybe that's the dream that if we realize, if the analysis on the twin realize that we are going to a blackout, then can we try to prevent this blackout by analyzing the system and coordinate some load shedding or some control action. So we are still far from that dream, but I would say that over the last year with the project that we did with you, Alistair, that we are closer and closer. It's hard to predict how much time it will take to do that, but I think we have to go step by step. I think that we have made quite a big step as of now. Tiens. Okay, so I think we have discussed that now several times. Know that we have to manage all the data, the cybersecurity aspect, but also the IP protections. So we have a lot of challenge to do, and one of the biggest challenges is nice to have kind of like a model, real-time model. It's nice, but how can you check that it is valid? And it's true that maybe at the beginning you install a power plant, a wind farm, or things like that, and you have made all your validation on a small-scale model. Maybe you do your commissioning, but this plant will be maintained, will be modified over time. So how can we track all the modification? So after some time, you may lose the ability to really predict or use the twin if you cannot update the twin. So I said one of the major points would be able to, in real time or online, try to validate the system model. And if the real system or if the twin do not react the same way, it means that something is wrong somewhere. So maybe we have to go to do some maintenance and things like that. But this would be quite a big challenge. So then implementing of many contingencies evaluation. We will not be able to test all the contingencies, but how can we use artificial intelligence to try to find the scenario or the best scenario that will give the answer as fast as possible. So this would be again one more challenge. Now the common data model. So maybe we can move to the next slide. Etienne, I think we have that, but the common data model is one of the big challenges, because over the time the utility, I mean at the planning department and many departments, AMT tools have been used, phaser tools, but the data, the model sometimes has been maintained by sometimes by a single guys, after that by an organizations, but sometimes the consistency or the validation of the data is not very accurate. And then we have to find the data for both type of models. You know, the phaser mode, which is more faster but more approximate model, and then the full detail AMT. And we have been working on that challenge over the last 4 or 5 years. And it is still very complex. That's a work in progress. And also because we need to interface with all the existing software used by planning and operation engineer. So this is one of the big challenge, and we have to find a way to go over it. Okay, Etienne. And what we found now that in order to introduce this black box model, now the only way, this was black box model, for example, with the PSCAD here was Fortran code 32 bits, and we have to interface with Windows or Linux with 64-bit. So we really need to interface the data in a co-simulation framework that is based on publish and subscribe. So every players around publish data, and they don't know by whom it will be used, and then they will subscribe to some data. Now, this could be easy for slow simulation with time step of 10 to 20 milliseconds. They are doing that in the defense, for war game, submarine, ship, and aircraft. But communication time are quite long. Here, we want to be able to work at the AMT levels. We want to work at below 50 microsecond step. It means that the communication between each object should be less than 1 micro to 2 microseconds to make sure that we don't spend too much time to communicate and less time to work. So we need to improve the tool. Right now, we are at quite a good step. We are able to make a very big demonstration, but we have to make it easy also. So we have to improve the usability. So because right now we're working more on the feasibility. So this would be one of the other challenge. Okay. And like you mentioned, Alistair, that this would be a big challenge to make sure that all the VAR integrators, wind farm and solar plant be able to connect their plant model to the global model approved by AEMO. You want to make sure that when you add a new plant, you will be able to see the effect of the other plant that are being installed, was installed before, and will be as is planned. But you want to make sure that each applicant will not see the design of the other manufacturers. So this will be a kind of a nice challenge to make sure that you will transform the power grid as a black box. In fact, you will do like all the suppliers. So how to make sure that you preserve the IP of each OEM. So this will be one of the next challenge that we need to find what is the best way to make sure that you can see the results, you can see the effect, you can apply scenario, but you maintain the security.